recording. Let's continue from where we left. तो हमारा था what we call Cauchy's root test. तो ये था कि अगर हमारे पास एक सीक्वेंस है of positive terms, a series of positive terms, तो an is positive, and if the situation is like this, limit n approaches infinity, the nth term जो है उसका nth root अगर converge करता है to some L, if L is less than 1, summation an converges. If it is greater than 1, summation an diverges. If it is equal to 1, that this doesn't, help, and it fails. We cannot be sure whether the series would converge or diverge in case the limit is 1. तो case 1 मैंने कर लिया था. Case 2 में हमने किया था कि if L is bigger than 1, then we can find an epsilon. We can choose an epsilon positive such that L minus epsilon is also bigger than 1. Right? Because you can choose a number between L and 1. So that would be L minus epsilon. Okay. So therefore, now since जैसे कि हम इससे पहले वाले केस में किया था, let us call this beta. Okay. Now limit n approaches infinity, a sub n 1 raised to power n is equal to L. It would imply that for any epsilon positive, there exists a natural number m such that a n raised to power 1 by n minus L is less than epsilon for all n greater than equal to m, which would imply that, of course, इसका मतलब ये है is bigger than L minus epsilon but less than L plus epsilon for all n greater than equal to n, which implies that L minus epsilon raised to power n is less than an is less than L plus epsilon raised to power n for all n greater than equal to n. And we can call this beta, जैसे कि हमने नाम दिया, यानी beta raised to power n is less than an for all n greater than equal to m. And of course, and since summation beta n runs from 1 to infinity diverges because it's a geometric series, of common ratio bigger than 1, of common ratio beta bigger than 1. So therefore, by comparison test, summation an must diverge in this case and runs from 1 to infinity. Okay. In case L is equal to 1, well, we don't know why, because it's easy to see that, if I take now for L equal to 1, the test fails. Why? You can see that it fails by an example. So, for example, 1 by n raised to power 1 by n in the limit n approaches infinity. हमने ये limit किया था actually पहले, so this is limit n approaches infinity 1 by n raised to power 1 by n, this is equal to 1. And limit n approaches infinity 1 by n square all raised to power 1 by n is equal to, of course, this is nothing but the same thing raised to power 2. So this is also equal to 1, right? But एक series converge करती है, diverges, while as summation n runs from 1 to infinity 1 by n square converges. So अगर ये limit 1 आता है, so we ये test हमें नहीं बताता कि what is the, whether the series converges and converges or diverges. And we can't be sure. It may happen that it will converge or it may happen that it will diverge. तो इसके बाद ये बिल्कुल ऐसा ही एक टेस्ट है, almost similar, although better slightly. वो है D-Alembert's ratio test. इसमें भी यही है कि whether the series eventually behaves like a geometric series. So let me write it down. If summation an and runs from 1 to infinity is a series of positive terms, you have a series of positive terms such that the limit n approaches infinity, but further ये limit exists करे an plus 1 by an is equal to some l, then वही जो इससे पहले था, then the series पहला converges if L is less than 1, second diverges L is bigger than 1, third the test fails if N is L is equal to 1. So we just prove it. मतलब जैसे पहले किया था case 1. Suppose L is less than 1. Now इससे पहले जैसे किया था almost identical. Then of course it should be positive because all the terms are positive. Now we can choose an epsilon positive such that L minus epsilon, L plus epsilon is still less than 1. Of course positive to hai because L is positive, epsilon is positive. Say now let L plus epsilon be equal to some number alpha which is less than 1, and since limit n approaches infinity an plus 1 divided by an is equal to L, it implies that for epsilon positive, any epsilon positive, in particular for this epsilon positive, there would exist a natural number m such that an plus 1 divided by a sub n minus L is less than epsilon for all n greater than or equal to m, which would of course imply that जैसे कि हमने इससे पहले किया था, this lies between L plus epsilon but greater than L minus epsilon for all n greater than or equal to m, or I can say an plus 1 divided by an is less than, let's call it alpha, which is right less than 1 for all n greater than or equal to m. So what we take the values of n. Now if you look at this number, now an divided by am can be written as am plus 1 divided by am into am plus 2. हम m तक जाएंगे, ये और ये कैंसिल. इसी तरह से am plus 3 divided by am plus 2 plus so on, multiplying product so on and so forth up to I go to an minus 1 divided by an. But as you can see, जो क्रॉस वाली टर्म्स हैं इस तरह से खत्म होती जाएगी. I think I should write an by n minus n, नीचे वाला नीचे, बिल्कुल सही. तो m plus 1 से n तक में गया और ये as you can see they all cancel out, so it is actually बचेगी खाली एक an यहाँ पे, क्योंकि ये यहाँ वाले टर्म के साथ cancel होगी, so it is actually the same thing. It's an by am, यहाँ पे an, right? अब हमें पता है अगर n m या उससे बड़ा है, जो कि यहाँ पे है, it is either m plus 1 m plus 2, है ना? So these all numbers are bigger than equal to m. So in that case this, ये जो सारे का सारा है ये m plus 1 by m plus 1, they must be all less than alpha alpha up to alpha. और कितने टर्म्स हैं m plus 1 से लेके n तक, तो it should be m minus n times, no, n minus m times, right? n से m निकाले तो बिल्कुल सही. So it implies that an by am is less than alpha raised to power n minus n for all n bigger than or equal to m. So almost हमारा हो गया, and alpha is less than 1. So it implies that अगर मैं यहाँ पे देखूँ, it means that an is less than a sub m times alpha raised to power n divided by alpha raised to power n. So which means that an is less than an divided by alpha n into alpha raised to power n, where alpha is less than n for all n greater than or equal to m. Now since now a raised to am divided by alpha raised to power n is a fixed positive number, because m is fixed, n is running afterwards, and m से बड़ा है n. So it's a fixed positive number. Let's call it k. It implies that an is less than k times alpha raised to power n for all n greater than or equal to m, and summation alpha n runs from to infinity, converges, because it's a geometric series of common ratio less than 1, since alpha is less than 1. Therefore by comparison test जो हमने पहले ही किया था, वो कहता है ये जो इससे छोटी बड़ी सीरीज है वो भी
सर
हाँ हाँ बोलो, आवाज आ रही है?
आपने लिया अल्फा लेस देन 1.
कहाँ गया?
हाँ सर आपने लिया अल्फा लेस देन 1.
हाँ
हेलो सर.
हाँ ठीक है.
सर आपने लिया अल्फा लेस देन 1, क्या वो 0 हो सकता है? फिर
नहीं,
लेस देन 1 फिर
पॉजिटिव
0 भी आता है.
पॉजिटिव नहीं पॉजिटिव. कहाँ गया? अल्फा पॉजिटिव है ना, ये ना l प्लस एप्सिलॉन. कहाँ गया मेरा? राइट, मैंने यहाँ लिया ना. तो अल्फा ये है l plus epsilon का, which is positive because l is positive and epsilon is positive. So therefore alpha is positive but less than 1. Negative नहीं हो सकता, right? ठीक है?
0
भी कहाँ, पॉजिटिव कह रहा हूँ, पॉजिटिव करना ये. Can you see the board? है ना, ये पॉजिटिव है, because l is positive. अगर मैं उसको एक और पॉजिटिव नंबर ऐड करूंगा तो वो आगे ही बढ़ेगा ना, तो वो नेगेटिव नहीं हो सकता, है ना?
ओके सर, ठीक है.
ओके, 0 भी नहीं हो सकता क्योंकि एप्सिलॉन पॉजिटिव है और l भी पॉजिटिव. Okay, so there we are. So this will converge. Now the case second. Case second is suppose L is bigger than 1. Almost वही जो आपने पहले किया. तो अगर L is bigger than 1, then we can find epsilon positive such that L minus epsilon is also bigger than. इसको हम थोड़ा आगे ले जा सकते हैं, 1 की तरफ, actually पीछे. Anyways, तो by the same argument as above, now by the same argument we will get as above हमें कुछ इस तरह से मिलेगा an plus 1 divided by an is bigger than L minus epsilon, which is bigger than 1. Let's call it beta, which is bigger than 1 for all n greater than equal to m. मैं लिखता हूँ there exists m belonging to a set of natural numbers such that this is true. अब again फिर से वही. Now मैं करूँगा an. Now for n bigger than equal to m, an by a sub m is equal to, मैं लिखूंगा am plus 1 divided by am into am divided by am plus 1 divided by am. मैंने क्या किया, m plus 1 आ गया, m आ गया. What should be the next? m बढ़ रहा है तो m plus 2 होना चाहिए. m plus 1, so on and so forth. I will reach n, and in the denominator I would have an sub minus 1. ये सारा का सारा, because these terms cancel, what you remains is an minus 1. But चूंकि n bigger than equal to m है, so this condition applies. So this should be bigger than L minus epsilon, rather beta. Beta कितनी times? Same idea जो इससे पहले था. So it is n minus m times, which implies that an by am is bigger than beta raised to power n minus m for all n greater than equal to m. जैसा कि हमने इससे पहले किया था, it means an is bigger than am divided by beta raised power n into beta raised power n for all n greater than equal to m. And of course, you know, am by beta raised power m is a fixed positive number. Say k, let's call it k. So we get, therefore an is bigger than some k times beta raised to power m, all n greater than equal to m, and summation n runs from 1 to infinity, beta raised power n diverges since beta is bigger than 1. Therefore by comparison test, जो इससे बड़ी series है, summation an would also diverge. तो बेसिकली दोनों का आइडिया सेम है कि अगर कोई सीरीज इस तरह से है कि इट इवेंचुअली बिहेव्स लाइक ए ज्योमेट्रिक सीरीज, तो फिर वो अप्लाई होता है रूल, एक्सेप्ट द केस दैट यू नो क्या बोलते हैं, the test fails, right? मतलब when the limit is 1. So we can again use this. वही अगर मैं लूँ summation 1 by n और summation 1 by n square, हमें पता है एक कन्वर्ज करेगी एक डाइवर्ज करेगी, बट अगर तुम लोगे इसका लिमिट है ना, n plus 1 by an अगर हम लें, so it would be basically n plus 1 का मतलब n divided by n plus 1, दूसरा होगा n square divided by n plus 1 का square, right? So अगर मैं इसका लिमिट लेता हूँ वो हो जाएगा 1. इसका भी लिमिट 1 है, ऑल्दो एक सीरीज कन्वर्ज करेगी दूसरी डाइवर्ज करेगी. So it fails. By the same example it shows that. So basically जो ये दोनों टेस्ट है ये तकरीबन सेम है, because they rely on the fact whether the series eventually behaves like a geometric series. So geometric series के लिए हमें पता ही है प्रिंसिपल क्या है. So इसके बाद एक और है what we call Raab's test, which is slightly better than these two tests. कभी-कभी जहाँ वो तो टेस्ट फेल हो जाते हैं तो ये चल जाता है. तो again it's for the series of positive terms. If summation an runs from 1 to infinity is a series of positive terms, idea फिर से वही है, series of positive terms such that again if we can have this limit limit n approaches infinity n times a n divided by a sub n plus 1 minus 1. Suppose this approaches a limit. Then the series would converge if L is bigger than 1. Converges if L is bigger than 1. It would diverge if L is less than 1. And of course, again, just like इससे पहले भी जानते हैं, the test fails if L is equal to. Again, proof भी इसका वही है, compare ही करते हैं ultimately, लेकिन slightly different than the root test and ratio test जो हमने इससे पहले किया था. So case 1 जैसा कि इससे पहले हम करते आए हैं, लेंगे हम L is bigger than 1 क्योंकि यहाँ converge इसी केस में करती है. Now we can choose epsilon positive such that L minus epsilon is still bigger than 1. So now since वही idea है, since limit n approaches infinity n times a n divided by a n plus 1 minus 1 is equal to L, so we would have the eventually we get, so सीधे ही मैं लिखूंगा, then there exists m belonging to the set of natural numbers such that what L minus epsilon is less than n times a n divided by a sub n plus 1 minus 1, which is less than L plus epsilon for all n greater than equal to m. Right? So which means that हमें सिर्फ ये वाला हिस्सा चाहिए, so I just write only that side of the inequality for this case. Okay, this is bigger than L minus epsilon for all n greater than equal to m. So that would give us, let's call this alpha to make this. Okay, so let's write it down. It implies that a n divided by a n plus 1 minus 1 is bigger than n times alpha, where alpha is equal to L minus epsilon, which is bigger than 1. So this implies that a n, या तो मैं इसको यहाँ ले जाऊँ या फिर मैं यहीं इसको एडजस्ट करूँ, यानी पहले मैं इसको ऐसे लिखूँ, is bigger than n alpha times, मैंने ठीक किया, मैंने गलत किया क्योंकि यहाँ डिवीजन में n आता है. It is alpha by n into, वैसे n को यहीं रखना चाहिए था, doesn't matter. So this is n alpha by n, यहाँ ये आ गया, alpha आ गया, और यहाँ an plus 1 आ जाएगा. Or I should write n times a sub n, n को वापस लाते हैं यहाँ पे, माइनस अब मैं थोड़ा और करूँगा n plus 1 a sub n plus 1. तो मैंने यहाँ क्या किया, मैंने n तो यहाँ ले लिया, n यहाँ आ गया, लेकिन मैंने सब्ट्रैक्ट किया तो I have to add a n plus 1 is bigger than alpha times a n plus 1. और इसको अगर मैं यहाँ ले जाऊँ तो इसी स्टेप में ले जाता हूँ, यानी चलो लिख देते हैं n a n minus n plus 1 a sub n plus 1 is bigger than alpha minus 1 into a n plus 1, right? And of course I have got this alpha minus 1 is positive. That's important because alpha is bigger than 1. Okay, next इसको हम इस तरह से करेंगे, मैनिपुलेट. नेक्स्ट हम कर सकते हैं इसको ऐसे. Okay, so then तो हम कर रहे थे just हाँ. Now what we do, तो I've got this thing. चलो मैं फिर से लिखता हूँ यहाँ पे. I've got a situation like this: n a n n a sub n minus n plus 1 times a n is bigger than alpha minus 1 times a n, right? Now now this is true for all n greater than or equal to m. Putting n, huh? क्या क्या मुझे पता नहीं क्या आ रहा है. हाँ, यहाँ n plus 1 होना चाहिए. यही था. जरा पीछे जाते हैं. हाँ, बिल्कुल सही है. Right. Now this is true for all n greater than or equal to m. So I put the values n equal to m. हाँ, ठीक है ना, लिखा ना मैं. नहीं, ठीक है. हाँ, राइट हैंड साइड पे n plus 1, राइट हैंड साइड पे भी n plus 1. Okay, now you put n equal to n plus 1 up to say n minus 1. So what you will get is, and add them. So you would get on the right hand side. तो अगर मैं तुम्हें लेफ्ट हैंड साइड पे अगर हम दिखा दें, so m दिया मैंने, so it would be m times am minus m plus 1 times am plus 1. फिर मुझे ऐड करना होगा. m plus 1 जब आएगा, so it will be m plus 1 times am plus 1 minus m plus 2 times am plus 2. मैं कह रहा हूँ लेफ्ट हैंड साइड में अगर मैं वैल्यू देता जाऊं, फिर लास्ट बट नॉट द लीस्ट इट शुड बी n minus 1 times an minus 1 minus an minus n times an. As you can see, ये terms cancel हो जाएंगी. So what would be left on the left hand side after adding would be simply m times am minus n times an. On the right hand side, it's very simple. So यहाँ just l minus 1 है, so it should be just am plus 1 plus so on and so forth up to an. So which is nothing but alpha minus 1 into Sn minus Sm, where Sn is the nth partial sum of the series, where Sn is equal to A1 plus A2 up to A. So हमारा काम हो गया ऑलमोस्ट. तो अब हमें इसको थोड़ा मैनिपुलेट करना है, यानी अल्फा माइनस 1 into Sn minus Sm is less than m times am minus n times an, now which is less than m times am. Why? Because an जो है वो पॉजिटिव टर्म्स है सारी की सारी, तो अगर पॉजिटिव सब्ट्रैक्ट करेंगे तो छोटा ही होगा. So which implies that alpha minus 1 times Sn, it is true for all n to length. So that's understood. It is Sn plus m times am for all n greater than or equal to m. So again, you can just write it now as Sn is less than 1 by alpha minus 1, which is a positive number, so I can divide Sm plus m times am. Now for all n greater than or equal to m. Now this is a fixed number. It means your sequence of partial sums here, it is bounded above, and since it's a series of positive terms, it must converge. So it implies that since ये जो अपना number था क्या था, 1 by alpha minus 1 into क्या था ये, मैंने कुछ गलत तो नहीं किया. हाँ, गलत किया ऐसे, लेकिन उससे ज्यादा कुछ फर्क नहीं पड़ा. यहाँ ये था, तो इसका मतलब क्या हुआ, इसका मतलब थोड़ा सा यहाँ अल्फा -1 यहाँ होना चाहिए डिवीजन में। ये मतलब फर्क कुछ नहीं पड़ा, इट इज स्टिल क्या बोलते हैं इसको, यस। तो मैंने क्या किया, यहाँ से हटेगा, ठीक है। यानी Sn जो है, Sn is less than Sm plus m into alpha -1 into Am. Now since for all n greater than equal to m, and since Sm plus m divided by alpha -1 Am is a fixed positive number, therefore ये जो sequence of partial sums है, the sequence of partial sums of summation n runs from 1 to infinity is bounded above. और अगर ये bounded above है, now since साथ में ये भी लिख सकता हूँ, since सब पे है, summation an is a series of positive terms therefore what, therefore it must converge. It must converge. So अगर L bigger than 1 है तो Raab's test shows that जो ना हमारा लिमिट था, it will converge. Now the case if L is less than 1, case second, if L is less than 1, again जैसे कि हमने इससे पहले किया था, then we can choose epsilon positive such that L plus epsilon is still less than 1. So now by the same argument as above, same argument as in case 1, so case second now I should have, there exists an m belonging to the set of natural numbers such that what, L minus epsilon is less than n times an divided by an plus 1 minus 1 is less than L plus epsilon, of course, which is less than 1 by our choice. Okay, तो इसको थोड़ा सा मैनिपुलेट करके, should I write it like this, हम यहाँ इसको इसके साथ जोड़ेंगे तो what do we get? We'll get n times, जो इसको 1 by n आ जाएगा इधर, then I have 1, ठीक है। यानी I should have an divided by an plus 1 should be less than equal to 1 by n plus 1 for all n greater than equal to m, so which I can also write as n plus 1 by n. Now if I compare the series with Bn, now let Bn equal to 1 by n, then it's clear that an by an plus 1 is less than bn by bn plus 1. वही तो है, for all n greater than equal to m, and summation bn n runs from 1 to infinity diverges. So therefore जो हमने एक और कंपैरिजन टेस्ट किया था, हमने 2-3 किए थे, उनमें से एक ये भी था कि अगर ऐसा होता है, so then summation an runs from 1 to infinity diverges. Okay, so ये थे हमारे कुछ टेस्ट, और भी एक दो है, लेकिन before going ahead I think we should do some examples. Examples coming in my book. Yes. So let me take some Raab's test हमने किया, तो Raab's test is generally considered stronger, मतलब जैसे for example एक example से वो clear होगा. If I take this set, so let me check this. हमें अभी कोई अगर मैं ऐसे कहूँ तो मेरा ये है एक सीरीज से अल्फा बाई बीटा प्लस 1 plus alpha divided by 1 plus beta plus 1 plus alpha into 2 plus alpha divided by 1 plus beta into 2 plus beta plus so on and so forth. अब अगर मैं un फिर क्या होगा ना an तो अगर मैं इसकी nth टर्म मान लूँ तो वो बन जाएगा 1 plus alpha into 2 plus alpha. अल्फा से शुरू करना चाहिए राइट क्योंकि अल्फा बाई बीटा है इसकी जो nth टर्म होगी वो अल्फा से तो नहीं हाँ ऑफ कोर्स क्योंकि 1 plus alpha फिर आ रहा है. So it should be n plus alpha plus 2 plus alpha, लेकिन it should only go to n minus 1 times plus alpha. And in the denominator भी ऐसे ही होना चाहिए. It should be 1 plus b क्योंकि पहले वाले में right क्योंकि 0 है यहाँ पे alpha है ना 1 की जगह 0 है तो ये 0 तक ही मतलब पहली टर्म में 0 है. So it should be 2 plus beta up to n minus 1 plus beta. Okay. Now if we check the ratio test, so अगर मैं लूँ limit n approaches infinity, इसके लिए ratio test बड़ा ideal था अगर हम सोचें तो क्योंकि ये खुद एक ratio है. So this would be equal to n plus 1 जब आएगा तो यहाँ n तक जाएगा यानी you should have 1 plus alpha 1 by n है तो it should be 1 plus beta into 2 plus beta n minus 1 plus beta in the denominator of 1 plus alpha into 2 plus नहीं मैं क्या करूँ alpha 2 plus alpha ठीक है so it is in the denominator n minus 1 plus alpha और अब आएगा ऊपर है n plus 1 so it should be 1 plus alpha 2 plus alpha n minus 1 plus alpha into n plus alpha और नीचे और इसी तरह से 1 plus beta 2 plus beta n minus 1 plus beta into n plus beta. So of course ये सारा cancel होगा. This is just equal to n अगर मैं इसका limit लूँ as n approaches infinity. So this would be limit n approaches infinity n plus alpha divided by n plus beta. So easily can be checked this is equal to what. So ratio test, D'Alembert ratio test doesn't work. लेकिन अगर मैं लूँ इसका limit n approaches infinity n times in a Rabb's test, an divided by an plus 1 minus 1, this would be limit n approaches infinity n times. इसका उल्टा करेंगे यानी n plus b